Hello, everyone, and welcome back to the Astro Imaging channel. We just have the three of us here tonight, and our presenter is Sid Frede. Terry's running the show. Molly's going to be looking at your questions over on YouTube. You know the thing about the questions where you got in the question mark. Molly, can you put up the little command about how to make a red question mark?
Yeah, I'll do that.
We'll have that. So if you have any questions of Sid, you can put them out there. And before we get started, I'm going to show our upcoming program. But before we do that, you do remember that Sid has been on here before. And unfortunately, he broke the internet halfway through and we lost him. And Molly and I kind of filled in best we could. But we didn't do a great job. And Sid's coming back here tonight in order to do the second half of his presentation. So before we get over to Sid, let me present now. Window, entire screen, share. So here's some of our upcoming shows. I'm sure you guys have seen this. We got some really interesting presentations next week. Gazo is going to be here. He has a very nice group of people, and they produce some fine images. He's going to talk about that. After him, Rod's going to be here. He has spent the last year or so constructing observatory in his backyard and gone through the normal trials and tribulations of doing that. He's going to talk about it. You remember he was on a while back and he presented some very interesting techniques, and I'm sure he's going to do a little bit of that while he's on next week. And after Rod, we have Ron Hedden, who's going to do some simple processing. Niels Haag, to be announced. I don't know what to be announced is, but it's something interesting. And then after that, we're going to have our workshop. And you all know that we have put up some very interesting data on the astroimagingchannel.org. And you should, if you haven't downloaded it yet or submitted any images, you should be sure to do that. I don't know, is the deadline passed for submitting images? Does anyone know that? Molly?
I don't think so, but I haven't been tracking that very closely. We haven't talked about it in a couple of weeks, I think.
Even if it has passed, that is a super data set. You should definitely download it. And it's from the Southern Hemisphere, which most of us really don't get. So I'm going to stop sharing. Oh, here we go. And I think that's just about all for introduction. So Sid, I'm turning it over to you. Give us the last half of that presentation that we missed last time. Sid, it's all up to you.
Okay, are we sharing yet?
You're sharing now. You should share your presentation and then go in the presentation mode.
Okay. Well, we're trying to get the presentation mode here going. Are we on?
You got it.
There you go.
All right.
Okay. Well, good evening. I'm Sid Frede, as Eric mentioned, and welcome to part 2 of Astrophotography as a Journey and Not a Sprint. As you mentioned, I presented part 1 back in March, and I guess I broke the internet, so we're back. So thanks to the Astro Imaging channel for having me back, and we'll begin from here. Basically, this is kind of a summary of a journey that I took starting pretty much in the COVID era of my journey into astrophotography. So just a very quick snapshot of myself. My background is in electrical engineering. I spent 15 years in the semiconductor industry, then ran my own business for about 35 years. I retired in 2018, just in time to join the COVID backyard astronomers. I had a fair amount of experience with DLSRs and shooting a lot of black and white and color. And then my interest migrated to astrophotography as a complete novice, and that's the beginning of my journey. I sort of look at astrophotography in three major categories: capture, calibrate, and create. And last session, I spent some time talking about really preparing for the capture portion of it. Talked about alignment, both getting mechanically and electrically connected, go-to alignment and polar alignment so we can do some photography, setting up guiding so we can track our target across the sky, talking about cameras, DSLRs, and dedicated Astro cameras. Focus, emphasizing the fact that if you're not in focus, you're recording garbage, no matter how good your equipment is, so focus is extremely critical. And exposure, sort of a controversial topic about what is the correct exposure, and the answer pretty much is it depends. And you can discuss that for many, many hours. And also talk about filtering for both one-shot color cameras and mono cameras. I'm in a Bortle 8 sky at best, so without filters, it would be pretty much impossible for me to try to capture any data at all. So now let's take a look.
Hey,
Yes.
Terry, the view on the slide is kind of cut off on the edges. While he fixes that, you can go ahead and
Yep. Fixing that. Yep. Okay.
Okay. Yep.
Great.
Go ahead.
We set?
Yeah.
Okay. So let's talk about targeting. Now that we've got our equipment put together, we're ready to do some imaging, and now it's important to be able to find a target. And that really requires two elements. That's a coordinate system to be able to accurately locate our target. And then some type of a planetarium system or a sky atlas or something that we can get a visual representation of what our target is going to look like. That coordinate system we use is the RA index system. And RA is right ascension. It's the number of hours behind the sun on March 21st that our target is. Why March 21st? I guess that was just a good date. We had to start someplace. And declination, that's the angle when our target passes through the meridian. That's the line between the north celestial pole and south celestial pole that divides the sky between east and west. It took me a while to get my head around the RA index coordinates especially. And I found that a couple of YouTube videos that were especially helpful, which I've looked at many times, and they're done by Dr. Michael Van Briesen. He's sort of the Mr. Science of physics, astronomy, math. He has a whole series of lectures, and I would highly recommend those two videos to really get a handle on what DEC and RA mean. So I'd like to try to pick a target that passes through the meridian at approximately midnight. And again, that's the line between the north celestial pole and south celestial pole, dividing the sky between east and west. What that allows me to do is to maximize my time on target for that particular night. So I can pick up the target in the east after the sun goes down, image that target to the meridian until approximately midnight, and then I can follow that target in the west until nautical dawn, until the sun rises, or till I get to about 35 degrees, and I don't like to image below 35, especially in my heavily polluted light skies. The data just isn't very good when you get that low in the sky and you're shooting through that much of the atmosphere. And also about that point in time, my neighbor trees come into play, so it's time to quit anyway. RA is a little bit confusing, and I made myself basically an RA calculator. And for an example, this is a target that I said I want to image back in March. So the way this little thing works is that I set the bottom to the particular time, here being 12 p.m. My meridian is at this point in time, and then the arrow will point to the RA value that will put my target at the meridian at midnight. So I made myself a little chart by month of the RA values that will put a target, again, approximately at the meridian at midnight in prime imaging position. And then after I've identified the target, a stellarium I use almost all the time. Telescopius is a web-based application. It's very, very good. Astrobin gives you a lot of information on a whole variety of targets. I also use Sky Safari, which is an iPad application. It's very, very good and really inexpensive. And for my larger scope, the 2000 millimeter SCT, I use a program called Nina to control that. And within Nina, it also has a Sky Atlas. Now, there are many, many others that essentially do the same thing that allow you to visualize your target. In imaging a target, obviously the moon is very important because, especially in doing color imaging, RGB, a bright moon creates havoc with trying to image in color. Narrowband is not quite so difficult in that you're looking at a much narrower bandwidth. but it still has to be considered when you're trying to pick a target. And again, we're looking for a target in March. And the criteria I was looking for, as we just saw from the RA wheel, was that for a value of RA between 10 and 12, I want to look at galaxies and nebulas. I want them to be above 35 degrees and no dimmer than 15. So if I do a search in Sky Safari with those criteria, I get a list of potential targets. So I picked M65. M65 has an RA slightly above 11. And this is just a screenshot from NINA, from their Sky Atlas, which shows me the target M65, the RA index coordinates, it's a galaxy and it's a Leo. And it also gives me a nice representation of where my target is in the night sky at sundown, when it crosses the meridian, and then towards sunup. So if I look at that target at about 35 degrees in the eastern sky, that tells me that about 16 minutes after 8 o'clock, my target is now at 35 degrees, so I can start my imaging run. At midnight, the target will pass the meridian at about 70 degrees to the south, which was shown in my diagram here. And then in the morning in the west, when my target sinks to about 35 degrees, I'm at 347. Well, what that allows me to do now is I can image almost 8 hours on a single target for that particular night. So I can collect a lot of data on that one particular target. And this is what my target looks like. By inputting your parameters for your telescope and your camera, you can get a very good representation of what your target will frame up like. This is a pictorial representation coming from NINA and Stellarium and then Telescopius. So I had a bonus here. Not only was I looking for M65, but in the frame, I've also picked up another galaxy now. I also put a note in my iPhone calendar for that particular target. In this case, I've got several targets that are going to hit the meridian in that time frame in March 19th or so. Every year, I set the target to come up again. So next March, I'll take a look at what's available. And then 1 week before that target comes up, I get a notice in my iPhone calendar to take a look at some potential targets. I also attach some graphics files, which gives you a picture of that particular target and some of the data. So I can look at my calendar and very quickly take a look at some potential targets for the month of March. Let's say we want to take a look at a target for August. So again, I want a target that crosses the meridian about 12 o'clock. If I look at this, set my wheel at August, I see now that my RA value is somewhere between 20 and 22. So I can select a target that will give me an RA value with that particular requirement, and I get a list of potential candidates. And the Crescent Nebula comes up, NGC 6888, a great target. And I then put a note in my iPhone calendar, record that, give me an alert when I get close to that particular time, and then make a decision if I want to include that in the target list for that particular month. I also say that I'm looking at the Lagoon Nebula, which in my area only rises to something shortly over 30 degrees. I'm looking at imaging that with a hyperstar, which gives me an f1.9. So in 3 hours, I can collect a lot of data. But I like to begin my capture time at 9 o'clock. So I set this at 9 o'clock. I look at an RA of 18, which is the target for Lagoon Nebula. That shows me that in mid-August, that target will be at the meridian about 9 o'clock at night. And here we are, a pictorial representation from Sky Safari showing my target at the meridian at August 13th at about 9 o'clock. And you can see I'm just barely getting above 30 degrees. So I've got a fairly short window where I can image that target and still not have to shoot through a lot of atmosphere. Here's my calendar coming up for March of next year. All these are targets that I've identified they're going to cross a meridian on that particular date. So when I take a look at that month, I can quickly click on those instances, take a look at the graphics files that I've attached to those, and make a decision for the targets I want to try to chase when March of next year rolls around. Any questions on trying to center in on a target or framing a target? I'll pause just a second.
No questions yet.
Okay, break in any time if you need to. So let's move on to some other areas that are important in capturing a target. Plate solving, dithering, the meridian flip, and automating the process. Years ago, when an astronomer wanted to zero on a target and capture some data, they would fire up their big telescope, maybe at Palomar, and zero in on a target, capture some images on a large photographic plate, and then the following day look at that plate. At that point in time, they would develop that photograph and compare the field of view to a known Astro database with the plate that they just developed. So they would solve that plate for a solution. And what this allows us to do is the fact that our go-to alignment doesn't have to be perfect. After a go-to, we can initiate a plate solve, and within now our personal computers or the computers we have, we can do a plate solve in many cases a second or even less. We don't have to wait till the following day to do that. That allows our target to be perfectly centered. That means we can image the same target on different nights or even years. I could pick up a target I did several years ago, add some data to it, and they would all be centered. Really required for a meridian flip where we're changing from the eastern quadrant to the western quadrant of the night sky. And there are a couple of programs, actually there are many programs, but I tend to zero in on Plate Solve 3, which resides on my computer. And ASTAP also works well. They're very quick, and they're resident on the my Windows 10 computer. Astrometry.net is a web-based location where you can do a plate solve. Of course, you require an internet connection, and it's not quite as quick as having something resident, but it's also very detailed and very accurate. Dithering, what is dithering? Well, every so many frames, and I usually use somewhere between 2 and 6, depending on the exposure link, the software will send a command to randomly displace the image by a small number of pixels, usually something around 25 maximum. That allows our software to recognize those hot pixels and remove them. It's also required for a process called drizzle, which I really won't talk about, but it's applicable to undersampled images. But the result is that the images are greatly improved with a very simple technique. So we take a look at a somewhat magnified image, and these are some time lapses, and I'm pointing basically at a hot pixel on the diagram, and I'm hoping that you can follow that hot pixel. And I'll go ahead and dither, and you can see the image moving around. But of course, the hot pixel, which is a property of a physical location on the sensor itself, does not move. So that process then allows our software to determine where those exist and be able to eliminate those when we do our calibration. And then we get to the dreaded meridian flip. For an amateur astrophotographer approaching this one for the first time, this one's pretty scary because basically our mount has to readjust when the target crosses a meridian. And if you'll remember, my targeting requirements is I'm trying to look for a target that I can stay on all night, which means that I'm going to cross a meridian at least once. So the mount's going to switch sizes of the pier, and it's going to swing 180 degrees. So if you can imagine the system self-destructing if that meridian flip is not properly executed. The camera hits the tripod, it breaks off, falls to the ground. That collision then collapses the tripod leg, and the scope falls to the ground and shatters the mirror. Not a very good evening. So that's why you must really be careful and verify that all the cables will not catch or snag during that flip, and all the equipment clears the tripod legs. What I've done in the past is basically put both the deck and the RA clutch, release those, and then try to swing the combination in all sorts of combinations so that I'm confident that the cables won't snag and I'm going to miss the tripod. This is a meridian flip that I did one night with my equipment about 1 o'clock in the morning. So basically what's happened is that I've imaged the target up to the meridian in the eastern sky. Now the target has moved to the western sky. So I'm going to have to change position. So the software issues a go-to command to go to the target now that it's in the western side of the sky. So as the equipment then repositions itself, you can see that I'm swinging basically 180 degrees. And if any cables or anything else are loose or going to possibly snag, that could create a disaster. So that's why it's very important to make sure that everything clears while you're doing that flip. Now, once I get to the new position, hopefully my go-to alignment has got my target fairly close probably to the center of my frame. And then the software issues a plate solve command, determines where the target is. If it needs to make an adjustment, it'll send commands to the mount to recenter the target. And when the target is centered, then the software will tell the guider to start to initiate and find a guide star. Once it finds a guide star, it will then lock onto that guide star, and we'll wait about 30 seconds to make sure that the guiding is stabilized. And then we'll go ahead and start the next imaging plan and go ahead and follow the target as it goes into the western sky. And by the time either we get to 35 degrees or the sun starts to rise or my neighbor trees appear, we're through with the evening and we've successfully done a meridian flip. We've been able to image the target all through the night, and we've got lots of data. And also, most important as well, when we're targeting the target at the meridian at midnight, we're also image a good portion of the target close to the meridian, which means we're shooting through the least amount of atmosphere, which means we'll probably get the best possible data as we're collecting data near that meridian. Automation. This is a real game changer. To automate a process, you have to have some type of a manual process. And this was the process that I primarily used. My scope was controlled with my hand controller via a Windows laptop. So at the beginning of the evening, I would set 3 alarms on my iPhone. One was when I'm approaching the meridian flip, so that I can mechanically make that meridian flip and make sure everything operates properly. Another alarm when my target approaches 35 degrees, because at that point in time, I want to stop imaging. And also, I have an alarm that goes every 60 minutes so that I can check my focus. So remember, I said before that if I'm not in focus, I'm recording garbage. And focus can change a fair amount during the evening with temperature changes, with position changes, with the whole scene changes. So it's really, really important to maintain good quality focus. I'll then power on the devices, go ahead and tell the software to cool the camera sensor, do a go-to alignment if I need to, polar alignment if required in order to be able to image. If I need to calibrate my guiding software, I'll then do a PHD2 calibration, slew to the target, focus on the target either by using some mechanical method like a Bahtinov mask or maybe an electronic focuser, do a plate solve, center the target, start the guiding, and then start the imaging process. And if I'm trying to image more than one target per night, this process will repeat itself. Oh yes, make sure you remove the lens cap. I'm sure nobody's made that error, but it does happen, believe me. So the manual steps requires constant monitoring. You pretty much have to be there all the time, or at least once you get going, wake up every 60 minutes, come out and check the focus. That results in a lack of sleep. And in Arizona, you may not have sympathy for me, but it does get cold here. We can be in the 30s or the 40s at night, and I've been out on the patio with my parka and a down vest and fingerless gloves and a stocking cap and my little red light. And for a desert rat, it gets cold outside. Now in the summer, which we're suffering through right now, we have boiling desert nights. And in fact, we just set a record. Today was 24 days above 110. We're still going strong. Yesterday, when I was on the freeway in my car temperature was reading 120. So at that temperature, it's impossible to cool a camera. The scope is hot to touch. The chair's hot to sit on. I'm sweating on the keyboard, and it's just miserable conditions. It's almost possible to image. And also, you need to be careful. These little critters crawling around the patio, so you want to make sure you're wearing shoes. Well, that whole process can be replaced by one button. So let me briefly show you what that looks like as far as my setup. I've got my laptop inside. It's connected to my local area network via Wi-Fi. And then sitting outside, I've got a Windows 10 computer, which I talk to via a remote desktop from this computer. I've also got a Wi-Fi booster out here because anytime you go outside your house, the Wi-Fi signal drops considerably. And then everything is contained pretty much in a plastic box to help keep the dust down and any other moisture collection. This is Nina, which is a software program I use to control that particular scope. And this is their dashboard, which looks amazingly confusing. But once you get used to it, it actually makes some sense. Well, let's just skip over that. But this is what a typical sequence looks like to capture the image for the evening. I've got a beginning, start, and an end. And in between, I've got a couple of targets that I'm going to try to image. The things that allow me to image remotely or without being present, or that one button imaging, are a couple of items. This is something that's under a global trigger for the meridian flip. It configures how that flip is going to occur that night. And there's also another module that can be added to Nina. And what this does, it texts me during the night as I complete various phases during the imaging. So as I complete a particular filter, I'll get a text message and that'll move through the night. And you'll notice here this particular evening, I switch to another target. I begin the same thing over again. When I complete a particular filter, I get a text message. And then in the morning when things are complete, I get a final text message that says shutdown is complete. Now that works great as long as there's no issues. However, if Nina runs into a problem that the software can't resolve, I get an annoying text message that tells me something is wrong. I don't know what it is. I can't resolve it. Well, that then allows me to go out to my patio, take a look at what's going on, try to correct the issue if I can, and then continue on through the evening. However, some evenings, and in fact, most evenings, I'll set up the system before dark and then start the process before dark. And I just basically push that button and I let the software take over. If I happen to be out for the evening or I've gone out for dinner, I'm over to a friend's house and I get that annoying message, what I can do is that I have a power strip on also the network, and I can basically cut the power to the PC and to the mount to make sure that nothing else happens. And when I get home, then I can take a look at it and correct that. The beginning and the end looks quickly like this. There's a command that says, don't start anything until nautical dusk. And the program will wait for that to happen. Also, then I will cool the camera. And there's a command that will copy every image as it's completed to the cloud. So in the morning when I wake up, all the images I've taken for that night will be stored in a cloud. In the end of the sequence, it shuts down the equipment, disconnects the items, warms the camera to 15 degrees, turns off that copying program, and then shuts everything down. This is what one of the typical imaging sequences look like for that one target. It gives me the RA and deck coordinates of the target. Again, shows me the target versus the evening position in the sky. And then I've got various filters with various exposure times and the number of exposures I'm going to take. But the key commands that allow me to automate the process are these. This is an autofocus after HFR increase. So, focusing can change from temperature, from seeing conditions, from position of the scope, and any number of things. But the thing that will change as a result of any focusing change is the HFR will change. So the software looks at a sample size and then determines that if it's increased by a matter of 5%, it will then call an autofocus. So that way I know that all through the night I'm going to be in focus, because if I drift out, the software will call an autofocus for me. After every image in the background, the software does a plate solve. If my target is drifted off center by, in this case, 174 pixels, and this can be determined depending upon your equipment, it will then initiate a plate solve in the background and then recenter the target to make sure that I'm staying on center of the target. So why this is important is that, let's say at 1 o'clock in the morning, a cloud bank rolls in and I take an exposure and there are no stars. The plate solve is obviously going to fail. Guiding is not happy because there are no guide stars. So I'll get error messages, but I'll continue to take exposures. And let's say at 3 o'clock in the morning, the cloud bank clears. The next image is taken, it will have stars. The plate solve will then probably be functional. I'll then determine via the plate solve if I drifted off center. If I have drifted off center, the software will issue commands to the mount to bring me back on center. And as soon as I'm back on center to the target, the software then will restore the guiding. So from that point in time, I now am collecting data again, I'm on center, and my guiding is working perfectly. And that's a one-button capture. Now, that's with the telescope that is my 11-inch telescope at about 2,000 millimeters. There's also a product called ASI Air, which works phenomenally well for systems probably 1,000 millimeters or less. And all those items we've talked about to date with guiding and controlling the camera and running an automatic focuser and exposures and filters and all those issues can be controlled by the ASI Air compound. And there are very few adjustments as you can make, which is good because it works really well. And certainly for focal lengths less than 1,000 millimeters, this is really a phenomenal product and works extremely well. Any questions about those items or that portion?
Sid, I don't see any questions over on YouTube, but I was wondering, looks like a lot of the targets that you're going after are RGB targets, not narrowband. And you're in Bortle 9 skies, so
right.
How does that work out? What are your limitations?
On that particular month in March, there are a lot of galaxies in the sky, and you're right. I try to image narrowband as much as I can, and with narrowband filterings, and I have the Opalong series, which is the 6.5 or 7 nanometers, but they still work very, very well. So later on, I'll kind of show you a quick snapshot of some of the narrowband stuff I've done.
So
What's
how
the
does it
name of
work
the-
out? I'm
Sorry,
sorry,
go
go
ahead.
ahead. No.
Go ahead,
sorry, go ahead.
Alex or Eric. Go ahead, Eric.
So how does it work out with those bright skies with your RGB images?
I've really kind of been amazed about how good I can do with some of the targets. I try to keep my exposure time small so that I'm not overrun by the light pollution. And I really was quite surprised with some of the galaxy RGB stuff that I was able to capture. And I'll show you some of the galaxies that I've done here towards the end of the presentation. It takes a little more effort, takes a little more attention and processing, but it is possible.
What's the name of that plugin you use for pushover? And is pushover, it's like a phone app?
If you go to Nina, it'll give you a list of all the available applications that you can choose to install or not. And I don't remember exactly the name of that particular add-in, but it's on the list of available add-ins, and it kind of makes itself obvious when you look at the things that you can use and can install.
Right.
I probably use about 10 of, there's probably 35 now available apps or modules you can install, and I use 10 of them probably all the time.
Yeah, they're awesome. Yeah. Okay.
Barbara had a question before I see it.
Yes.
That's the question I just asked.
Oh, that's the plugin question?
Yeah,
okay.
yeah.
Sorry.
No
All
worries.
right, back to you.
All right. The 3 phases of astrophotography: capture, we just talked about, and create, we'll get to in a minute. And now we're into calibrate, which is, for me, probably the most confusing area of the whole process of astrophotography. And I think if you look on cloudy nights or follow some of the Facebook forums or some of the threads, you'll find that everybody's confused. So what I'm going to attempt to do in the next few slides is to demystify image calibration. So wish me luck on this one. When you take an exposure, you get the good, the bad, and the ugly. The good, that's the photons from the target. That's going to become our picture. The bad is anytime we apply power to our sensor, we get dark currents and hot pixels and offsets and fixed pattern noise and lots of things we really don't want, so we have to find a way to get rid of the bad stuff and get it out of our photo. The ugly, those are all the optical aberrations in the image train. That's the dust that sits on our filter, no matter how much we try to clean and keep it sealed. Vignetting, we have a circular image train, but yet we have rectangular or square sensors. So we'll typically get darkening on the corners or the edges, and the calibration frames help us remove that. And you may have internal reflections inside the image train, but just a whole number of things that just add ugly items to your photo. So our single exposure looks like this. We've got the good and the bad and the ugly. The good is in here with our signal. That's the photons from our target. The bad is dark current and bias and things that are contributed by turning the power on our sensor. And the ugly are also photons we capture that are part of the signal. So how do we get rid of? Oh, also I'd like to give a shout out to Adam Block. I've taken these images from one of his presentations, and he gave me permission to use those. So he has an excellent presentation talking about the calibration process. So basically, here's our light frame, the good, the bad, and the ugly. We take a picture of the bad and get rid of it. We take a picture of the ugly and get rid of it. And what we wind up with is a frame, a single light frame that has hopefully only the good photons. That's our picture. Well, how do we get rid of the bad stuff? We get rid of the bad stuff by taking dark frames and bias frames. And the way I do that, or I do that at night to try to eliminate any other extraneous light or light leaks, but I have my dew shield with a lens cap, and then I have a black filter, which either goes into a filter drawer if I'm shooting my one-shot color, or also my monochrome. And also I had some some light leaks from the camera to the filter wheel, so a little black electrical tape helps seal that up. So basically, we're trying to take an image basically of our sensor without any photons at all hitting the sensor. And the dark frame has to be at the same exposure and the temperature as the light frames, because dark frames are time and temperature dependent. And I typically take about 25. I'll take those at some typical exposures I use, 60, 120, 300, maybe one or two others. And I take those at 0 degrees centigrade. And I'll take a look at that a little bit as to why I chose 0 degrees for my imaging here in Arizona. I also take bias frames, and those can be taken at very fast shutter speed. I think it's about 1/5000th of a second. And I usually take about 100 of those because they're so easy to take and it doesn't take long at all. Well, the nice thing about dark frames and calibration frames is that they'll last at least 6 months, maybe 12 months. Your sensor doesn't change characteristics very much at all. So once you've done a series of dark frames, you can keep those in your library and use them for a long period of time. Excuse me. So maybe there's a cloudy night or something during that time frame, and I'll just fire up my system and let it run all night and take a bunch of dark frames and create a new dark library. I'm going to quickly look at a couple of curves and I will get rid of these, but this is the curve of read noise for the camera that I'm using right now, the ASI 2600. So you can see here at a gain of about 100, the read noise jumps to a very low value of 1.5. This is the dark current versus temperature of that sensor. And as I mentioned before, I usually image about 0, but you can see as you reduce the temperatures, the dark current reduces very quickly. But if you look at 0, the value of 0.00195 is really still pretty small. So if you take a look at that contribution, say at 0 degrees C, at a 300-second exposure, which is about the longest exposure I take, the read noise is 1.5. That's not going to change. The dark current is at 0.00195, and the total noise is the square root of the sum of the squares. Well, that's 1.61, which is about right there, which is negligible. So I don't worry too much about trying to drive my cooler down to -20, because I really don't gain much other than stressing my cooler and burning up a lot of battery power. So that's kind of the reason I've chosen 0 as kind of my standard here in Arizona, especially during the warmer months when things get warmer and it gets more and more difficult to cool the camera sensor. Flat frames. Boy, this is a difficult one because I spent a lot of time trying to understand flat frames. And again, the presentation by Adam Block was especially helpful in looking at that. But what my flat frame looks like as far as the way I take them, I've got 4 layers of a white t-shirt on basically a quilter's hoop. I've got an LED panel that I think I paid about $40 for with a low, medium, and high setting. It's a 5-volt panel, so it connects right into one of the USB ports on my Windows 10 computer. It has a low, medium, and high setting, but the low setting is still not low enough in many cases, so I have a neutral density filter. Well, you can go to an optical supply house and buy a neutral density filter for a lot of money. They can be very expensive. But what I did is I went to my auto parts store and I paid $6 for a roll of window tinting film, and that works great. I try to take my flat frames between 1 to 5 seconds at about a 30,000 ADU. And if you look at most of the threads, that's something that a lot of people will agree on. And what we're trying to do then is to basically take a fairly well illuminated signal, because we're trying to get a good picture of those optical aberrations. So if you take a look at a curve here at this side of the curve, we're at basically 0 ADU, which is as black as you're going to get. And this side of the curve, you're at 65,500 or 535, and that's as white as you're ever going to get. And so what I had done, and it took me 2 or 3 nights to do that, was to play with the layers of t-shirts and optical filters and exposures so that I basically produced a linear curve from about 1 to 5 seconds. And at 3 seconds or so, or 2 seconds, I'm getting about 30,000 ADU. So this is a linear portion. It's an ideal curve in order to take flats. And if you take a look at what this results in the flats that I'm taking, I take my LRGB flats at the same time with the t-shirts, with the neutral density filter, my LED panels on medium, and I get exposures between basically 1 and 3 seconds at around 30,000 ADU. In taking flats with the narrowband filters, the sulfur, hydrogen, oxygen, they let much less light in. So I remove the neutral density filter, I kick up the panel to high, and I'm getting exposures between 1 second and 5 seconds, around 30,000, still in that linear portion of that curve based upon this combination of elements. So ideal ideal flats, and they work very well for me. This is a typical master flat frame, and you can see these little round circles, hopefully. Those are little specks of dust or dust motes, probably sitting on the surface of my camera glass. And you can see the darkening around the edges, some of the vignetting, and I got a dark band across the top. This actually was, I have an off-axis guider, and the prism was extending a little too deeply into the image train, so it was causing a shadow. I since corrected that, but in any case, even with that there, the flats took care of all that and do a good job of correction.
Sid, can
Now,
I ask you a question?
yes, go ahead.
Is that a quilting hoop that you have there?
Yes, that's a needlepoint hoop. You can get it at any art and craft store.
That's great.
And it's you can get them any size. And I got my t-shirts at Walmart for about $3 for 6 of them. So no great loss, and it worked really good. Now, the flat frame is a light frame. And as we just talked about, a light frame has the good, the bad, and the ugly. So when we're taking that flat frame, we need to get rid of those elements. Now, what I used to do was I took something called a flat dark frame or a dark flat frame, basically at the same exposure of the flat frame, at the same temperature, to capture that dark current or those aberrations of that sensor, and then use that to calibrate the flat frame, and then use a flat frame to calibrate my light frames that I've taken from my imaging. Well, in taking a look at that, if I take a look at my temperature at 0 degrees, an exposure of 5 seconds, you can recall the read noise from my previous charts hasn't changed. The dark current at 0 hasn't changed. If I take the square root of the sum of the squares, I'm still at 1.5, which basically says my dark frame didn't do a thing. Now, the one thing I need to be concerned about, though, is that there is a fixed pattern noise, which is part of the dark frame. So if I don't use a dark frame to calibrate my flat frame, I need to use a fixed pattern noise or that bias frame. So that dark frame that I took at 1/5000th of a second, which is my bias frame, it is included in the dark, and it's basically a result of the manufacture process. So I go to my dark library, pull out my bias frames, calibrate my flat exposures, and end result of that is I can do all 7 filters, flat frames in about 15 minutes, and they work great. Now, this is a flat panel. This is a flat panel. It's about 20 feet by 20 feet, and it's at the Lowell Discovery Telescope in Happy Jack, Arizona, about 7,500 feet. And it's a 4.3 meter reflector telescope, and the mirror sits down here, and you can see the secondary mirror up there. And I had the good fortune of being able to tour that about a month ago with my son and my wife. So even the big guys have to be concerned about calibration frames. They say they take their flat frames about once a week using this large flat panel. They have a large intense light down below that shines up on the panel that evenly illuminates, and they point the telescope at the flat panel and take their flat calibration frame. So as amateur photographers, we have it easy, I guess, when it comes to taking our calibration frames. Okay, well, what's that look like? This is our light frame that we took, and we take a look at that and say, well, you know, there's nothing there. Where's the image? Well, if you take a look at the histogram, with this side being completely dark and the right side being completely white, most all of our target is down here, because when you go outside at night and look up at the sky, it's dark. Well, our software has the ability to stretch that image so we can see what's there. We basically say, well, this side is going to be black, and this side over here a little bit is going to be white. And if we have the software stretch it, now we can see what our target looks like. Well, now I can see that I've got 2 galaxy cores. It looks like I've got some spiral arms. That looks a lot like M51. So that's only one frame, though. And there certainly isn't much data there that we can make a picture out of. And that's why we take sometimes hundreds of frames or multiple hours of exposures to be able to pull out the image and to reduce the noise. A dark frame multiplied quite a bit looks something like this. And you see those little white dots. So there's those little nasty white pixels or hot pixels. So every time we apply power to our sensor, there's some pixels in there that are very hungry. So there's electrons running around without any presence of light. They start grabbing those electrons, fill up the well, and all of a sudden they became a 1. So they become white. So this is what we have to do to eliminate those as in our calibration process. And there's our good old flat frame with the dust motes and the vignetting and everything else involved. So we can take all those together, and then we can finally start working about making our picture. And again, the good, the bad, and the ugly. Take a picture of the bad, get rid of the bad. take a picture of the ugly, get rid of the ugly, and we wind up with nothing but our good photons, which we can make our photograph out of. Again, this is the YouTube video from Adam that talks about the calibration process. Excellent, does a great job of explaining it. And again, I thank him for letting him use his graphics. And there's also a really good discussion in Sky and Telescope about dark frames and bias frames and everything involved in calibration. Both those are excellent resources in trying to understand the calibration process. Any particular questions? It's still a kind of a controversial area because it's not easy to do, and it takes a lot of thinking about what you're trying to accomplish.
We're having a
So
big
we're good?
discussion over here.
Okay.
Yeah, troubleshooting some problem for some people. But yeah, don't think there's specific questions right now unless I missed one. Yeah, go ahead.
Okay. Well, finally, we're getting ready to actually create a picture. So this is M51. There's 133 exposures at 300 seconds at 1960 millimeters at f7. So we take the 133 light frames, 25 dark frames, or 25 flat frames. At this point in time, I was taking flat dark frames, put them all together with 208 frames, toss them into our software, and it'll generate one master light frame that we can start a picture from. So that's our single exposure again, and stressing when we look at it. And this is the one master light frame that has been generated from those 208 frames. And we take a look at that and say, well, you know, that's not very impressive. I can certainly tell that that's M51, but there's not much color there, and there's a lot of noise, and I've got some stacking artifacts, and, you know, where's the picture I want? Well, here comes the area where you're going to spend a lot of time. This could be a couple hours, it could be a couple of days, or maybe longer, but processing the data that you've gotten and teasing out those colors and getting rid of the noise and getting rid of the artifacts and trying to come up with a photograph that you're happy with can take a lot of time. And now whether you use Photoshop or PixInsight or combinations of those or a multitude of processing tools, it's going to take a fair amount of time to develop some expertise to do a good job of pulling out that data. And that just becomes a problem of experimenting and playing. And it just takes some time to get familiar with the software tools and then kind of develop your own process as to how to bring out the data that's sitting there in that master frame. And now we get into something that is another controversial topic, and that's science versus art. Science really kind of revolves around the capture of the data and the data analysis. That's telescopes and mounts and alignments and polar alignments and spectrographs and exposures and coordinates and flips and scripts and pixel math and everything else that's involved in capturing data and analyzing data. Art is the processing and interpretation of that data. And here's where we have a lot of controversy. I'm pretty good, I think, at the data part now. I feel comfortable with that. I'm not so good at the art part. I got a decent eye for composition and colors and framing, really from my experience in shooting lots of DSLR photos over the years, but my mind really sputters when it comes to the artistic flair, and my stick figures aren't even very good. But the power of the processing software opens up a whole new world in turning all that data into something beautiful, at least in your own eyes. So processing is a very individual journey. The basis of color calibration, background extraction, noise reduction, sharpening, build the base of the processing, and the masking and color and hue and saturations and cropping and all those other items are really avenues open up to your individual taste. The bottom line is that there's no such thing as a wrong interpretation of the data. You can make it your own and make it unique because you're creating art. Many of you are familiar with Russell Croman, who over the last year and a half has introduced some incredible artificial intelligence tools, which has greatly assisted the amateur astrophotographer in processing images. Back in 2003, he made the following quotation. Let me go ahead and read this. By now, there is one point that should be made fairly plain. Virtually all astronomical images that are prepared for general viewing have been significantly modified from their original scientifically useful form. Because of this, and because the degree of modification is largely determined by the judgment and the taste of the person doing the processing, we must quickly dispense with the hardline notions of what is right and wrong in image processing, where these also become the province of various individual opinions and personal preferences. In other words, preparing an image for general viewing is largely an art. It may be an art that's guided by scientific notions and attention to detail, but it is still an art. This goes back to 2003, so we've been arguing about it ever since. This is a screenshot of one page from AstroBin of M42. And when I took this screenshot, which was just a week or so ago, there were 19,184 images of M42 on AstroBin. And you can see not a one is similar to another. Different colors, different saturations, different hues, different orientations, different magnifications. Every one of those 19,184 is different. And there's nothing wrong with any one of those 19,184. Those are the individual interpretations of the person processing that data of the M42 image he created. This is my first image, and there's nothing wrong with it, so don't laugh at it. This is one I took with my DSLR, probably about a 30-second exposure, and you might be able to recognize it as M42 if you have a creative mind. But the one thing that stands out for this, and anyone who's processed M42 knows that you can struggle for a long time trying to process the large dynamic range of M42 and still be able to pull out and recognize the trapezium. Well, my very first image of M42, even though it was horribly out of focus, there's the trapezium. So that was a major emphasis. And this is what got me hooked. This was the one photograph that got me hooked on trying to pursue astrophotography. So about 9 months later, I produced this photograph. Much better, much more distinct. You can certainly sell it as M42. Wound up finding lots of nebulosity around the M42. And, I can take a look at this now, and there's still lots of things wrong with it and things that could be improved. But this really verified the fact that in my horrible borderlight skies, that I could actually be able to produce some pretty decent images. And this is a list of images that I've taken over the last few years using one-shot color, using either my Canon DSLR, good old Rebel T3i, or the ASI 533 from ZWO one-shot color. And again, some galaxies, some narrowband stuff, one I especially like with the Horsehead Nebula. All these are posted on AstroBin, so if you're interested in looking at the details or the exposure times or filters or total hours on target, feel free to do so. Recently, over the last year and a half, I've been working a lot on narrowband images, and this is using the sulfur, hydrogen, and oxygen filters of 7 nanometers, and then chasing other things. Here's some nebulosity in the Fishhead Nebula, and the Pillars of Creation and the tadpoles and other things. So again, these are all on AstroBin, and feel free to take a look at the details of how they were produced. A couple that I especially like back from last year. IC 417, the Spider Nebula, and then Thor's Helmet. Just a gorgeous target, and I really love shooting this and had a lot of fun pulling out the colors and doing the processing. Really like this target. Shrimp Nebula, I spent a lot of time here on processing trying to tease out the tentacles of the shrimp, and that was a lot of fun to be able to try to pull that out of the image. This one, 733, not particularly because of the detail, but it's just the magnitude. This galaxy is, I think, 41 million light years away. This galaxy is 290 million light years away. And this galaxy is 370 million light years away. So the time and the distance is just really tough to get your head around and to just imagine the immensity of the universe. And now with James Webb, we're looking at galaxies out at 13 billion light years away. And now there's some controversy and discussion about maybe the universe is really 27 billion. So as we learn more and more about the universe, all of our past known knowledge has modified and changed. This was a galaxy that I took back in February of 2022, and it was my first attempt to take a separate hydrogen alpha filter and then add that to an RGB image and trying to accentuate the hydrogen alpha portions of the galaxy. And it didn't turn out great, but that was my first attempt. So later on in November, I reshot that same galaxy. And with different processing techniques and some of the different tools, some of which were introduced by Russ Krollman, I got an entirely different image. And now and adding the H alpha to it, you can see these large areas of hydrogen alpha in this galaxy, which are huge star producing regions. This was an image I took back in May of last year of our infamous pillars of creation. And I worked in processing with this and really wasn't satisfied with how it came out. But at that point in time, that was kind of the best I was going to be able to do with it. So in January of this year, I reprocessed the same data. Did not take any additional data, but this time I was able to use some of the new tools, SPCC and BlurX and NoiseX and StarX and generalized hyperbolic, as well as some of Bill Blanchard's pixel map equations, an entirely different target. And I was really pleased with the way this came out and the details that you can accomplish by using some of these new tools. It was a real change in my opinion of what you can do with some of these targets, going from here to here with the same data. This is a planetary nebula I shot that I was really enjoyed. It's almost 25 hours of data, I think, on this one. It was fairly faint and fairly small, but I was really happy with the way the colors came out and some of the detail that I could get. And this was the picture that we saw previously of M51 that I did a couple of years ago. And this is one I did recently where I reprocessed it. New data, and again, utilizing some of the new artificial intelligence tools and working on an improved process flow. So big difference. It's fun to see the improvement over time that you can accomplish as far as what you've learned. Some more images from last year, all primarily monochrome with filters, some galaxies, some nebulas. Again, all on AstroBen if you'd like to see some of the details behind these photos. Some more. I just recently bought a 300 millimeter system, which I'll talk about later, but these are some of the wide field images that I just recently took with the 300 millimeter scope. And this is one that I discovered something called the Herbig-Haro items. And this one was fascinating. I spent a lot of time researching this and spending processing time on that. And this is an image that I'm especially happy with. This is the recording of an astronomical activity that probably I'll only see in my lifetime once. This is the supernova that appeared in M101 just a couple of months ago, SN2023 IXF. So I, as well as probably thousands or tens of thousands or maybe hundreds of thousands of amateur astronomers across the world, zeroed in on 101 and tried to capture a picture of the supernova that exploded in the M101. So this is one I was very happy with and I'll hang on to a long time. I talked about the improved tools available and briefly mentioned improved processing. And it wasn't that long ago that when I would collect some data that I was really hesitant to start processing it because I really didn't know where to start. You watch so many YouTube videos and one guy says, do it this way or do it that way or try this or include that or don't include that, or it's very, very confusing and you can get very confused about what to try to do. So I basically tried to take all of that and simplify for myself a process that kind of gave me a basis for beginning processing. And now I don't hesitate at all when I pick up a new data set and try to process it. So basically I've got a few processes. I've got a process that I follow for narrowband processing for the traditional Hubble palette. I've got a process I follow when I mix the sulfur, hydrogen, and oxygen filters in the RGB combinations of different varieties to get different color sets, and it requires a slightly different processing flow. The processing flow for monochrome filters doing color as well as one-shot color are pretty similar. One thing that I do is when I take narrowband images, I immediately throw away the stars because the narrowband stars are pretty crappy. Whenever I shoot narrowband, I'll shoot some RGB and I'll pull those stars out. And also when I'm shooting color, I'll pull those stars out as well and I'll process those separately. And then later on in the process, I'll recombine them with either the narrowband images or back into the color images. Also, this is the process I talked about, adding hydrogen alpha to some of the galaxies. I'll shoot an RGB galaxy and also shoot some hydrogen alpha, process that separately, bring it back into the process flow, sometimes at this point, sometimes later, to try to add some punch to those hydrogen alpha regions of the galaxy. Also, when I'm shooting RGB, I'll also shoot some luminance filters. And again, luminance filters are processed separately, and they come back into the process later on. When I'm doing narrowband, sometimes I will take the sulfur, hydrogen, and oxygen filters, combine them with integration, producing one frame, and produce that, what is called kind of a superluminance, and bring that back into the process. So lots of combinations of possibilities, but most all these follow kind of the same process with just different variations depending on what kind of gets added in later. And as I go through these, then I'll just start checking out the blocks as I go through these areas. No two process ever remains the same. So anytime I do a process, some of these things get moved around, or maybe some get ignored, or maybe some get added. But this gives me a frame of something to follow, so that when I start a process, I have a pretty good idea of the path that is going to follow. Again, everything's included on AstroBin if you're interested in taking a look. And any questions on what I've done as far as putting together a flow and using some of the tools and processing?
Yeah, we've got a couple questions in the chat here.
Yes.
One, so on the chart you just showed, what does X form and GraphX mean?
Which one was that?
X form and GraphX.
Oh. Yes.
Yeah.
Where am I here?
Let's see. I see a DBE plus GraphX in the narrowband column.
Yeah.
And X form and LRGB
Yes.
column.
Yes. GraphX is a new program that's been available recently that does really a pretty efficient job of removing gradients. Historically, I'd use something like DB out of PixInsight to do the gradient removal, but I found lately that I can take almost all of my images and run GraphX, and the gradients are greatly reduced. And in really difficult gradient situations, you can run DBE after you run GraphX, perhaps, to kind of fine tune it. But in most cases, GraphX is a new tool that is being available. In fact, I think it was just a few weeks ago, one of the gentlemen did a tutorial on GraphX.
You mean Graxpert?
Graxpert, yeah. Graxpert, right. That's what
okay.
I call it. Yeah, it's Graxpert. It's a great tool. It's worked very well for me, and I really like it.
And what's a X form? X from?
I'm sorry?
In the LRGB and one-shot color columns, after your add H alpha, you have Expo, X from. They're asking what that means.
Yeah, exponential transformation is one of the processes in PixInsight. Frankly, I haven't had a lot of success in using it, but I usually try it just in case. You know, it's one of those things you can try it. If you don't like it, you just ignore it. But it's easy to do and it's simple to try. And you know, I haven't seen a lot of reason to keep using it. Or maybe it's because I don't really know how to use it, but I haven't seen a lot of use of it.
Another question, this one's from Tarek. Are you happy with your Optolong 7nm narrowband filters? How do you like them?
I think they work exceptionally well for me. You know, people say that the 3 nanometers are even better, but for $1,000, I'm very happy with what I got. I think they work pretty well, and you can see all the narrowband stuff I've shown or is on the AstroBin site is all done with the 7 nanometers Optolong filters.
Awesome. And a question from Brent: how much of your journey was self-taught versus or self-taught or solo versus connecting with the community?
Probably 70%, and a lot of that was spent on just hours and hours of YouTube, seeing what people had done, looking at YouTube videos. And again, as I mentioned, trying to sort out what works for me and try to ignore the ones that don't, so that when I start an image process, I'm kind of comfortable with my flow versus somebody else's flow.
Mm-hmm. Another question here from Isaac. What do you do in your sharpen step? What processes do you use there?
Yeah, let me back up. I've tried unsharp mask occasionally. Seems to work reasonably well.
Mm-hmm.
And even though you're not supposed to, I've actually tried to run Borex late in the process with a very low percentage. And I'm actually satisfied with what that does. I've been told that that's a no-no, but it sharpens a little bit without being obtrusive. I found that works not too bad.
Would it be possible to share this this spreadsheet? Some people in the chat would be interested in having a copy of it. If you have a OneDrive or a Google Drive, we can put the link into the video description after.
Yeah, I have a OneDrive where I can put it and just share the Excel file.
Okay. Awesome.
And what, just to send you an email to sort of what the location is?
Yeah, that'd be perfect.
Okay, we'll do.
And I think that's all the ones in the chat so far.
Sid, I have a question or actually a comment.
Yes.
I think it's kind of important when we do this processing to differentiate what Russ does in his blur exterminator, which is not sharpening.
Right.
He tries to imagine what it would be if it wasn't blurred,
Correct.
as opposed to sharpening tools would actually add contrast to structures, and that's sharpening, whatever process you use. So I think we have to give Russ some credit here for producing an AI application which gets to the heart of what the nebula should look like.
Oh, absolutely.
Without sharpening. With sharpening
I've
being
tried to
completely
do
separate.
deconvolution the long way before, and basically gave up. And with Russ coming on board with Borax, which is basically the deconvolution process, which actually works very well, it's amazing. I mean, it takes so much time out of the process and produces such amazing results.
I think everyone agrees.
Yeah, it's great.
Yeah, that's all I've got in the chat. Eric or Terry, any other questions? Or
No, I didn't see. Sid, did you have more, or is this the end of the presentation?
Yeah, there's some more.
Okay.
Okay. Go
Okay,
for
continue.
it.
Okay.
Yes.
Now, recommendations for a newbie. And this is primarily focusing on deep sky objects because that's really my primary interest. So, if I had it to do over again, what would I do? Don't do what I did. That's what I would do. And that I started out with a 200 millimeter or 2000 millimeter scope and tried to go from there. I basically did it backwards. A small field of view, guiding was a problem, plate solving is a problem, focusing is a problem, meridian flip has to be very precise. I learned quickly, but the whole process was painful. So what would I do if I started over? Basically, utilize that DLSR on a tripod. Just go out in the backyard and take a bunch of photos and have fun with it. And then migrate to a wide field of view scope, something in the 300 to 500 millimeter range. And by all means, take advantage of the tool ASI Air and those focal lengths, because it's really a good tool. And then don't be too aggressive in adding equipment right away, because your interest may change. You may decide that maybe deep sky isn't for you and you want to do planetary or something different. So the equipment is slightly different and the software is slightly different. So kind of give it a time to understand what is of interest to you and then pursue it from that standpoint. And again, utilize ASI Air. It's a great tool, works very well. So spend some time with the DLSR. Get a remote shutter so that you can take some time exposures, and consider something like a star tracker or something similar, because then you can track across the sky and get some long exposures on certain topics or certain targets with your DLSR. Use Deep Sky Stacker. It's free. It works very well to calibrate and stack your photos. And Photoshop is a great place to start. Most people have had some experience with Photoshop, and you can use that to process your photos. And then starting to add your telescope. And that can be a refractor, a Dob, or a Nude, or almost anything. Skywatcher, Explore Scientific, ASCAR, Williams Optics, Orion's. There's a lot of people that make really, really good scopes in that area. But I would encourage you to spend as much money as you can on the mount and the tripod. It will certainly handle your first system effortlessly and make everything easy, and gives you the avenue to expand as you add equipment or maybe bigger scopes. The AM5, the strain wave mount, I'm very, very happy with. And so far, I would certainly recommend taking a real good look at that one, as far as a nice, lightweight, powerful mount. And migrate to an Astro camera as soon as you can. The ability to cool the camera greatly simplifies the calibration process, and you'll be very satisfied with that. Guiding, a 50 millimeter, 150 millimeter guide scope is good. Guide cam, get the best you can, because you're going to be using it a lot of places later. And of course, PHD2 is free and it works exceptionally well. Software, ASI Air. My first software I used was Backyard EOS, controlling my Canon DSLR from my laptop, and then Deep Sky Stacker and Photoshop. And I've pretty much migrated now to PixInsight and use PixInsight exclusively to do my processing. And YouTube. But again, you need to choose your mentors wisely. And these are some of the people that I follow. I think they do some great information, and you can pretty much trust that the direction, what they're talking about is probably pretty spot on. Also, when you're collecting all those YouTubes, make sure you create a bunch of folders, because you'll quickly become overwhelmed with YouTube videos. In this particular case, this one is like HA to RGB. So these are some YouTube videos that I've looked at that talk about how to add hydrogen alpha to an RGB image. So it allows me to quickly go here if I've forgotten something or maybe refresh myself. This is the system that I bought recently, which is the one I should have started out with. It's a 300 millimeter scope. It's a 120 millimeter guide scope. This is the ZWO 120 Mini, great little guide scope. The mount is the AMF5. The HEQ5 is also a great mount, a little less expensive. The camera, DSLR is great. This particular one is the ASI 2600 one-shot color. The SI Air controls the whole system, and it works great. So you really can't learn from a book. As soon as a book is published, it's obsolete. Things are changing so quickly in astrophotography, and we can take a look at the new tools that have been introduced just in the last year. So a lot of YouTube, a lot of forum, a lot of Facebook groups, and again, pick your primary interest. Is it galaxies, nebulas, deep sky, planets, Milky Way, light angle, whatever it's going to be? But you kind of zero in what's of interest to you. And again, don't buy your equipment all at once. Add with your experience. And don't wait to try it. Go out in the backyard and take some photos with your DSLR. And by all means, enjoy your successes. But also, be prepared to spend maybe 20% of the cost of your system on software and training. Don't skimp on the training. It's going to save you a lot of time and frustration. And there are several courses that are available. Adablock has a great one. He has a fundamental course and a Horizons course with lots and lots of videos. And there are a number of people. Masters of PixInsight has some great stuff that they do. So there's a number of ones out there that offer some training that will greatly accelerate your path. So anyway, start now, take lots of pictures, stack with DSS, process in Photoshop, enjoy your success. And great pictures, great fun. It's easy as can be. Your family will be amazed because they love you. Your friends really won't understand, and they'll just kind of nod their head and say, well, yeah, that's nice. But astrophotography is hard. But the point thing is to don't be discouraged. Enjoy your triumphs along the way. What I've learned, and when I started out, I kept a journal, and I've been a little negligent in doing that. And I would encourage, if you're just getting started, to do that. When you encounter a certain situation and a problem that you solved, jot it down so that you can refer to it later. Keep a log of your imaging sessions so that you can refer to those also. You'll find that of great use to you as you go down the line of astrophotography. What I've done so far in last year is lots of YouTube stuff. I've learned a lot about PixInsight and processing, kind of established a standard flow. Automated my system. That was huge. Basically, I go out in the evening before it gets dark, set everything up, punch the button, and watch the data collect. I found that especially in my skies and bad Bortle skies, I'm trying to extend the amount of time I get on a target. I shoot for 20 hours, and somewhere between 10 and 20 is usually helpful as well. I've improved the guiding last year, improved my ability to take flats. As I mentioned, I can do flats now in 15 minutes. And basically, I'm allowing the software to reject the bad frames. Before, I tried to be too concerned about looking at the frames and trying to remove the frames before I went into the stacking process. And narrowband, shooting lots more narrowband. So what's coming up next year? Again, concentrating on putting more time on the targets. That is huge in developing better photographs, especially in crummy skies. I'm going to reshoot some targets and compare my progress. Experiment more with some of the narrowband combinations. Plan the targets now for the next 3 months coming up. Haven't done any mosaics. I want to try that. So it's one thing that's on my calendar to take a shot at. More combinations of narrowband and RGB color. And then getting better with the luminance. I showed that on my flow. I had a number of areas where I'm working on luminous frames, but I need to understand that better and be more proficient at making that effective. And also amateur astronomers' contributions to science. There's a Society of Astronomical Sciences. I would encourage you to check that out. Amateur astrophotographers can significantly contribute to the advancement of science. And I think you'll find that that's very challenging and very interesting. And I'm going to try to do some of those things this coming year. So it's pretty much the end. And really, it's just kind of the beginning, because when you're dealing with a hobby that deals with infinity, there's lots to do. So again, thanks for allowing me to present this evening. I hope it was useful. I will put up that one flow chart so that's accessible, and that pretty much takes care of it. Remember, it's a journey, it's not a sprint, so be sure to stop and enjoy the journey as you go along the way. So any questions, be happy to try to address those, but that's kind of my last 3 years.
Awesome. Yeah, thank you. I don't think we got any additional questions after the last slew, but some compliments on your presentation here, and a lot of people who've had similar journeys and similar reminiscing.
we share the pain.
Sid, you can stop sharing if you like.
Okay. Hang on here a second.
You have to stop
we off?
sharing. Don't close the window.
Yep. We should be off.
It should
Yep.
be off. Oh, that's great. That's great presentation. You held your audience there very well. I think people became interested and questions started to pile up there towards the end.
Good. Hopefully it was
excellent.
useful.
Well, it was supposed to be fun too. This all has to be enjoyable so that
That's
when
it.
we get to
hobby
the
should be
end
fun.
and
Challenging
we
and
see
fun.
it, when we see the image on our screen, if we don't get a little excited, it's probably time for another hobby.
Mhm.
So
All
we
right.
have all our questions.
Yep.
We can you can hang with us for a little bit after we close
Okay.
out the broadcast if you'd like. It's not too late. So I think we're all set. Anything else, Molly? Are we all
Nope. I think
get to
we're all
hang it up
good.
for this evening?
Yep.
All right. Turn it over to Terry. Everyone that's out there, thanks for joining us, and try to come back next week. Here, wave. Got the princess wave. Is that the princess wave?
Good night, everybody.